right, this is Unit 8, this one right here, Lesson 1, Student Activity Sheet number 2. It is 8 pages. It is very repetitive, as algebra is. And I'm going to give you a little, spiel before we begin, okay? The whole point of this whole thing in algebra that we're going to be doing, and I'm going to talk about this in class when I start teaching again, is the properties of equality. These are common sense rules so that you can prove that the math you do and the solution you get is correct. It's very important you understand math is one of the most stringent, most strict subjects that there is, period. It's more strict than science. In science, there are plenty of things that we believe are true that are not fully proven. They call them theories. And theories, evolution is still a theory. It's a theory that we can't prove every little detail of it because it's too complicated and too big to prove. There are lots of theories that exist in science that are not, because, we just look at the way things work and we say, hey, this seems to be the way it works, and we notice. In math, however, we actually have to prove things 100% logically. There's no way around it, okay? So whenever you get a solution in mathematics, it doesn't mean diddly squat unless you can prove it. There have been plenty of people who have proven really complicated theorems in math and come up with amazing ideas. And if they don't have their proof correct, it doesn't matter. It doesn't matter at all. And so people spend most of their time in math actually being able to prove what they think. That's a big deal. Okay? So that's if you can understand anything about mathematics, that's really the heart of it, is can you prove something's true? So what we're doing most of the time is we're just learning the rules. You're learning how to add a number to another and figuring out what it works, what it makes. And right now we're learning the basic rules of how to prove something's true. Now what that's going to look like is the steps for solving an equation, okay? And the properties of equality that we're going to use are the addition property of equality. That says if two quantities are equal and I add the same amount to both of them, then the resulting amounts quantities will also be equal. An example of that is if I said 5 equals 5, and then I add 2 to each of them, plus 2, plus 2, and I end up with 7 equals 7. Notice they started out equal. As long as I add the same amount to each of them, they stay equal. If I added 3 to both sides, I would end up with 8 equals 8. As long as two things start out the same, and I add the same amount to them, then they stay the same. They stay equal. They don't stay the same as where they started. 5 doesn't equal 7. But if I start with 5s and I add 2 to each of them, I end up with 7s. That's important in an equation because there's always an equal sign in the middle of an equation. So as long as I do add the same amount to both sides of an equation, I'm keeping it equal. And that's the whole goal, is to be able to prove every step of the way when I have an equation that it's equal. I'm going to keep this simple because there's also a subtraction. There's a subtraction property of equality. And so what that looks like is, well, I have 5 equals 5. And I take something away from each side. Let's say I take 3 away. Minus 3. Minus 3. Well, if I take away 3 from each side of the equation, I end up with, look at it, 2 and 2. Because I took away 3 from one 5 and 3 from the other 5, and now they're both 2. Are they equal to each other? Yes. Yes, indeed they are. Okay, so that's the first rule. That's why when we're solving some things in equations, we are always like, let's add 2 to both sides, or let's add this to both sides, because you're allowed to do that, because it keeps the equation equal. Okay, that's why it's called a property of equality. The other 2 properties of equality are the multiplication and the division. Property of equality. Now, I lump these into one because you'll see when we do this assignment, a lot of these things, they're very repetitive. Multiplication and division are very related, and addition and subtraction are very related to each other. And that will come up a lot in the future of mathematics for you, okay? Even in high school. So be aware of that. Okay, we have 2 quantities. If, you know what, I'm just going to do this really fast because almost all of it's the same. The only difference is instead of adding and subtracting, you guessed it, we multiply and divide. Oops. Multiply. Slash divide. The same amount. And we have to change this a little bit. Because we don't use math, we don't say it the same way. If 2 quantities are equal, and I multiply or divide them by the same amount. By the same number, that makes sense. And the resulting quantities will also be equal. Let's go with, okay, we have 5 and 5. This time I'm going to multiply by 2. Yeah, I'll just use X, that's fine. It's not great, but I'll use capital X. It looks a little bit more like multiplication. So if I do times 2, then I'm going to get 10 and 10. It doesn't matter what number I start with. If I double it, it makes the same number as if I double the same starting number, right? As long as they start the same. If I double them, they end the same. If I triple them, they'd be 15 and 15. They'd still be equal. As long as I multiply them by the same amount and they start out equal, then they'll end out equal to each other as well. If I divide, let's make this be 15 and 15, just because I'm lazy and I don't want to think about decimals right now. So if I start out with 15 and 15, and I divide the 15 by 3, well, I get 5. I get 5. Start out the same, divide them by the same thing, they end out the same. And that is the division and multiplication properties of equality. Now, the reason that I treat them as the same thing is I can add a positive number, but I can also add a negative number. So this would technically be the property of addition now, because I'm adding negative 3. But really, that's the same thing as subtracting 3. So you can add a negative or you can subtract. Those are the same thing. And so really, addition and subtraction properties, they kind of overlap once we add negative numbers. The same thing happens with multiplication and division. Because if I multiply by 2, that's actually the same thing as dividing by 1/2. And if I divide by 3, that's the same thing as multiplying by 1/3. So you can actually kind of overlap these. And that's why I'm kind of just listing them as 2 things instead of 4. Okay? I am done rambling about that. But the whole goal is to be able to show step by step that they've given me something to start out with. And each step of the way, I follow these properties. That's why I add to both sides of an equation. That's what we've been doing. And this is why it's allowed. It's a property that everyone understands and agrees is true. Because we can have this discussion in class. Can you think of any numbers that this doesn't work for? No, I don't think you will be able to. Okay, so this is a tried and true common sense rule, and we use it to test to see whether your answer makes sense based on the information they gave you. Okay, so let's do this. We've got question number 1. X plus 2 equals 7. Now, we all know the answer is 5. 5 plus 2 equals 7. However, our goal is to use these properties to prove it. So the way we always do it, and this is what I expect everyone to do in their assignments from now on for the rest of the class, okay, is type out what they, or write out. I mean, X plus 2 equals 7. Start out with what they said, what they gave you to say, okay? Make this slightly bigger so it's easier to see. I'm also going to zoom in a little bit more. Okay, so I have X plus 2 equals 7. That's what they said right there. You always write down what they said, because that's the assumption. We're assuming that this is true, that this equals that, okay? And then what we're going to do is, if you have been doing algebra at all, you'll know that I need to subtract 2 from this side. Subtract 2. You know what? I'm going to make this red. I can't do it that way. Okay, I got to go like that. That's 2. That's 2. And so now I end up with X. Well, I took away 2 from here. Dang it. And I end up with just X on the left side. So instead of a number 2 bigger than X, I have X. And over here, instead of 7, I have 5. So up here it's saying the number 2 bigger than X is 7. I take away 2, and now I have just X instead of a number 2 bigger than X. And that happens to be 5. This is using the subtraction. I'm going to say property of equality, POE. Okay. Now, I'm telling you, this is something we're going to do in geometry as well, just so you know. So when you're in geometry next year, you're going to review this, and you're going to be like, oh yeah, properties of equality. Mr. Thorson talked about that, and it won't be any different. It is a rule of mathematics that never, ever goes away. Now we have X plus 2 equals 7. Again, they say to do it 2 different ways. Here's what they're looking for. I think this is cheap. It's silly, but sure, whatever. We're going to say plus a negative 2. That is perfectly okay, but who wants to do that? I don't. But I mean, it's good to know that you can, I suppose. There are times in mathematics where this is an easier way to write things. So there are times when you'll be like, well, I guess you can write it as plus a negative instead of subtraction, and that's cool. But most of the time, we would just subtract 2 because it's just easier. Who likes adding negative numbers? Almost nobody. All right. So then we've got, and guess what? When I add a negative to a positive, they cancel out, and I end up with X over here, and I end up with 5 over here. Oops. Over here, and it's no different. I'm going to really quickly switch to this. We're going to do some crossing out. Traditionally, we cross that out to show the whole point was that I subtracted the 2 so that instead of a number 2 bigger than X, I have the number that is X. So I took away 2 from each side. Okay, I try this one. This one says 15D equals 300. So let's type it out. 15D equals 300. So 15 times that number equals 300. If I want to get rid of it, one thing I can do is to divide both sides by 15. This is the way I would do it, just for the record. This is the way that makes sense. I'm going to put that in there. Go back to here. I'm going to divide both sides by 15. So now instead of 15 Ds, I'll end up with 1. Because if you have $15 and you split it 15 ways, how much do we each have? $1. If you have 15D and I split it 15 ways, that's what division is. Then I end up with 1D. That's all that this division thing does. It's just a chance to get rid of a multiplication. Now, there are lots and lots of ways to think about this, and we will do it in the near future. Oops, no. 300 divided by 15 is not 300. Let's see, it takes, oh gosh, 2 15s makes 30, so 20 15s is going to be 300. All right, and I do this really quickly. That's fine. Now, another way I could do this is to, let me type it again. And this is, again, a way that I wouldn't do. The one on the left that we just did, that's the fastest way to solve this. However, you could do it by multiplication. So I could say times, I can, let's see, we're going to say, here's what we'll do. So I'll write this one because it just doesn't make much sense. Times 1/15. And times 1/15. Now technically that's multiplication. When I multiply by a fraction like that, think if it was 1/2. Times by 1/2, you're really just dividing by 2. If I times by 1/15, I'm really just dividing by 15. So this is no different. Okay, just that the first one uses division technically, and the second one technically uses multiplication. So let's see here. D still equals 20. And then let's see this, the way it ends up happening. Oops, I didn't want to do that. I want to go back to this. I wanted to go to this, and the way it ends up happening is these cancel out just like those did, and I end up with 1 times D, which is D. Over here, I end up with 1 times 300, and I have to divide that. 300 divided by 15, just like over there. It's no different. Okay, so I forgot to type some things. Let's see. I'm going to actually go ahead and I'm going to put this. Control C. Delete. It was just thinking about format so that the future is subtraction, property of equality. This is addition, property of equality. Because I added something to both sides of that equation. This is the division, property of equality. This is the multiplication, property of equality. Erase our speckle a little bit, and we're done. That's the dealio. Okay, so let's solve some things with this now. That was all there was in the lesson, just for the record. If you go into AgileMind, there's not much more to say. They just show, they call it the multiplicative inverse property, which is just, yeah, there's a lot of stuff. And we'll talk more about it, but they have some information here if you wanted to see it. Okay, so now we're going to use algebraic operations to solve this. This is our assignment from the last one where we said $75 is how much money we have to spend, and we're going to solve for M. Okay, now we technically solved that before, and we're going to use properties. So let me type it in. I'm going to put the 75 first, but it doesn't really, no, we'll type it the same way they did. 29.95 plus 0.16 equals 75. And whenever you see something like this, what you're going to do is isolate the variable. Some classrooms will say that's true. We're trying to figure out what it is. But when we're doing algebra, we're going to use properties of equality we just discussed. We're going to use those to try to get rid of everything around the variable, if there's one variable, that is. So that's m. So I want to get rid of the 2995 and the 0.16. The way we do this is we always start by trying to get rid of something by adding or subtracting, and then we move to multiplication and division. So this right here is being multiplied by m. And the way we get rid of things is by doing the opposite. Because think, if I have a number and I add 5 to it, and then I take 5 away, those cancel each other out. That is why, if you ever were in an earlier class, you learned about 3 and -3 are additive opposites. You might have had to learn that term. This is why. This is why. So when you do this math, you can be like, how do I get rid of something? Well, you do its opposite. So if I have something adding 3 to it, and then I subtract 3, those cancel each other out because they're opposites. You can also learn a little bit about, actually I'll type the next step. So the next thing we have to do, so the first thing I do is I use addition or subtraction. So I'm going to subtract 2995. I have to do it from the left side of this equation. Now notice it's the equation. Some teachers will have you draw lines straight up and down here like railroad tracks. That's a great way to remember that you're doing the same thing to each side of those railroad tracks. But I do not grade based on whether you put those lines in. But I do want these steps. So this right here is called the subtraction, POE, property of equality. Subtraction, POE. There were other opposites. You can also say that 1/2 and 2 are multiplicatives. There. So these are the two types of opposites that you might have learned. Also, the ones that don't do anything, like multiplying by 1 or subtracting by 0, which we sometimes use multiplying by 1 in math a lot later. So we'll get to that. But right now, we're just keeping it simple. So I took away 29 from each side. I'm doing two things at once because I have to type at the same time. Sorry about that. But that got rid of this, right? So there's no longer 2995 here. Let me do that better. Okay, going back to the words here. So that leaves me with nothing but the 0.16m and the 75. Now I need to get rid of that 0.16. Now notice 2 over 1 and 1 over 2 get rid of each other. When I divide by a number and then I multiply by that number, they cancel each other out, right? If I have 5 divided by 5, I get 1. If I have 1/2 times 2 or 2 over 1, they cancel each other out. When I multiply something by the fraction with it on the bottom, then it goes away. So that's basically what's happening when we divide by that number. So if I divide a number by itself, 2 divided by 2, then I get rid of it. So that's why we're going to get rid of this 1.6. If I'm multiplying by m, 1.16, all I have to do is divide by 6. And that will get rid of them. They'll cancel out. I have to do the same thing to the other side, 0.16. I'm going to put this little line in so you can go like, oh yeah, that's what he was doing. Dividing both sides by 0.16. These guys cancel out. Because I multiply by a number and I divide by the same number, nothing happens. Try it anytime. Take any number you want, multiply by 0.16, and then divide by 0.16. It'll just go back to where it started. Okay, this is called the division, because I divided. division property of equality. So these, what I'm doing in the parentheses, are important. They're saying list the algebraic property that justifies each step. That's what we're going with for. So now that leaves me with nothing but m on this side. Instead of 0.16 m's, I have 1 m. And I divide this by 0.16 and I get 281, I believe. 281.56. You can double check that. I don't really even care if I'm right because it's about right. And the point is, if someone asks, how do you know that that's true? You can say, well, you told me this information, and this right here makes sense. So this has to be true. And this right here makes sense to me because it follows the rules of mathematics. So this must be true if what the original information you gave me is true. And that's the way it works. That's the way mathematics works. We get information, we follow the rules that we painstakingly learn over our lives. And if you get an answer, you can prove that it's right 100% of the time. This is the glory of mathematics. Okay, so now we're going to do properties right here. So I would just call this the original statement. Okay, another cool word for it is the given. Okay, you'll get that in geometry a lot, given. Basically, that's the information you gave me. It's the given information. Okay, very typical for people to use this in logic and mathematics, that word. Okay, so they gave me this information and I wrote it down. Awesome. So now what happens? Now we're taking, what is happening to both sides? Well, they have this and they added -7. Since they added, we call this the additive property of equality, or the addition property of equality. I'll do that. Okay, now here, what's going on here? Well, we have 7 plus that. This is technically called the associative property. Remember the associative property? That says that 3 plus 4 plus, let's say 3 plus 4 plus 5 equals 3 plus 4 plus 5. Basically, oops, that's not true. Okay, it's saying I could add these guys first or not. Okay, so I can, yeah, it's not a big deal. All right. So then we said I can call this. What happened? Well, we added 7 and -7. Those are called additive opposites. Additive opposites add to 0. Okay, what happened next? Now we're just explaining what happened, okay? Now the thing is, some of these are not exactly justifying. They're not like proving that it's okay. We're just saying, hey, this is what happened. I can prove step by step. I can explain to you what happened so that there's no way you can doubt that I did the work correctly. That's the goal every time when we're doing algebra. That's why we always say show your work. It's part of what you're learning. This right here, we could just say 5x plus 0 plus 5x. Anything plus 0 is itself, right? You can also call that the additive identity, which is anything plus 0 stays the same, equals itself, keeps its identity. That's called the identity. When I add 0 to something, it doesn't change its identity. The identity, the additive identity. Okay, now what happens? Now I subtracted we say 22 minus 7 equals 15. I agree. Would you agree that that's true? I would. This right here is called the division property of equality. Why? Because I divided both sides by 5. And if I divide both sides by the same thing, it has to stay equal, so I'm allowed to do that. 5 divided by 5 is 1. That's called the multiplicative inverse, multiplicative inverse. Aren't these cool words? That you're loving this. And anything times 1 is itself. That's called the multiplicative identity. Multiplica anything times 1 is that's bad. There, I'm going to change. I'm not going to change this, but a number. There. This could also be yeah, we're good. Okay. So we got lots of fun things. There's a lot of information here. Hopefully I gave you enough information. That's what this looks like. We're basically saying, I can explain to you every step of the way what happened here. Some of these words you may have heard, some of you have not. I'm sorry, we'll get better at it. This is my first, I have not even taught you this stuff yet, so there we go. Okay, here, we got all this stuff. Now I've got a bunch of x's over here. One thing that helps me with this process, first of all, remember the first step is always 5x plus 4 equals 3x plus 8. You always write out what they've got. Okay, one thing that helps with this process sometimes is I can say like 5x's and there are 3x's over here. And I have plus 4 over here. Plus 4. There are lots of great ways to learn this stuff. And we're going to think about it like a scale. Oops, that's not plus 4, that's plus 8. So what's going on is we're taking things off the scale in this particular one. Notice this one has more x's than that one. I can take away 1, 2, 3 x's over here, and 1, 2, 3 x's over there. I'm taking the same amount off each side of the scale, so it should stay balanced. That's the same concept with the multiplicative and the additive properties of equality. It's a whole thing. It's a whole thing. It's the same concept. This is actually where it came from. It was way back when people in the Middle East mostly, because that's where algebra was invented, more or less. India, Middle East, yeah. But yeah, they weighed stuff with scales. And so these properties were very clearly shown with scales. But that's a long story that I don't need to go into. Okay, so what am I going to do? I'm going to take away 3 x's from that side. I'm going to take away 3 x's from that side. Put this over so it's centered better. That's going to leave me with 2 x's over here. I didn't do anything to 4. 4 minus, and there are no x's over there. There's none left. So there's just 8 over here. That's what we end up with. Notice I have 2 x's and a 4 over here and an 8 over there. Just what we have right there. Next thing I'm going to do is I'm going to get rid of 4 from each side. So if I get rid of 4 from each side, oops, that's going to get rid of this. And this guy right here, instead of having 8, there's going to be 4 left. So now I have 2 x's on this side and a 4 over there. I take away things from the scale until there's very little left. So I'm going to go back in here, I take away 4, minus 4, minus 4. Leaves me with nothing but a 2x on this side, nothing but 4 on the other side. What times 2 makes 4? I divide both sides by 2, and I end up with x equals 2. I divided each of them in half. I should write that in because we are doing formula of equality after all. So let me type this in. I'm going to go 2, 2, and 2 here. Oh, zoop, and zoop, and there we are. So this canceled out, that canceled out, that canceled out. I got rid of things. Each step of the way, I got rid of something on the scale until I was left with x equals 2. So the way algebra is really working is it's saying, I followed the rules, so if what you told me is true at the beginning, then x must be 2. That's the only thing that will make it true. And I can check that. If I plug a 2 in, I get 2 times 5 is 10, plus 4 is 14. Over here, I get 2 times 3 is 6, plus 8 is 14. They're equal to each other. And I promise you, there's no other number that I could possibly plug in there. Only 2 will make this side equal that side. You can spend all day trying to find other numbers. Plug in a 10 and I get 50 plus 4 is 54. 30 plus 8 is 38. 54 does not make 38. I can't plug in a 10. There's no number but 2 that makes these equal. And that's a powerful thing to be able to figure out. Okay, now we're going to solve this one. I'm going to be going a little faster. What I would do first is get rid of an x. Remember, you always type the equation first. I want you to see, I know it takes forever. Write it out if you have to. This is why we do this on paper usually. It's very important in algebra to be able to show your steps. That's the whole point. The whole point is to be able to prove your work. Okay? If you want to do anything in mathematics, you're going to have to learn how to do that. So I got rid of 1 x from each side. I got rid of the x on the left side, so there's nothing left on the left side except for 4. And instead of 3 x's on the right side, there's 2 x's. Notice, I don't say 2x, like 2 times x. I just say there are 2 x's, because that's the same thing. When I multiply, it's saying how many of something there are. So 2 times x is 2 x's. All right, we have 8. I'm going to get rid of the 8. Ooh, minus 8. 8. 8. Notice, I just subtracted too much from this side, and that's okay. I have 4 minus 8. Remember from your old school algebra time, and maybe 8th grade actually, you did, maybe 7th grade actually, you did a lot with negative numbers. Okay, and math 2. And we have 2x, and I had 8 minus 8, nothing. I don't bother to write 0 like they did up here, because everyone knows when there's something plus 0, it just becomes 5x. So this step I usually skip. Why? Because life is short, and everybody knows that that becomes a 0 and disappears. So, in case you were wondering. So now I have to divide both sides by 2, just like we did on the other one. And I end up with negative 2 equals x. Now, I'm going to tell you another property called the symmetrical property. Honestly, I teach math, and this is stupid to me. But some math teachers are really stingy about it, and so I want you to be aware. We might as well follow the rules for a while. We'd say negative 2 equals x, but really, I want to say that x equals negative 2. Obviously, that's true. But there's actually a thing that's called a symmetrical property. It says if one equals the other, then the other equals the one. They equal each other. So I can write it in either order. Okay? And sometimes that comes in handy in certain proofs in geometry, but it's a very specific thing, and mostly it just seems stupid. And I don't blame you if you're like, well, that's dumb. Okay, so moving on to B. B looks like this. 2x plus 3 equals x minus 2. Hopefully you're solving these on your own and you're checking your work. That's what I would like you to do. But at the same time, I'm tired and make sure that you get all of the stuff you need and putting a whole bunch of wait time in here. So I just have to sit here and it would be boring for both of us. So please pause if you want to take the time and solve these. That would be great. 3 equals, what's going on here? 2. X is gone. I got rid of an X from each side. There were 2 over here. Now there's 1. There was a 1 over here, and now it's gone. And there's just a -2 left. Negative goes with the number that it's in front of. Okay, unless you subtract it from something and then you add them together and they make a new number. But mostly negatives just stick to the number that they're in front of. All right, so I'm going to take away 3 from that side, so the x is by itself. One thing I'm not saying nearly enough, and I'll be saying a lot in class, is always look at the variable. Notice I start out by getting rid of variables until they're all gone from one side. So this side doesn't have any more variables left, and this side has 1 left. Next, I get rid of everything around the variable by doing the opposite. So I look at the variable, I say, hey, it's being added to 3. Let's subtract 3. And that's the trick. Okay, talk about that more in class. So that leaves me with nothing but the x on this side. And -5 here. -2 minus 3 is -5. Let me really quickly go in here. We'll say cancel that. Cancel that. Each time that you do something, it cancels something out. Cancel. 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 Okay, because that's the whole point. Now, we'll talk about this in class, but you could do anything. You could actually do different amounts. You could do steps. You could add whatever you want to both sides and it would stay equal. But we're doing strategic things. So the first thing I do is I ask myself, are there x's on both sides? How many x's can I take away before that's gone? The answer is I can take away 2 x's from each side and then this will run out. So I'm going to do that. I'm going to take away 2 x's from each side until they're gone, so I'm going to say minus 2 x's over here. Say minus 2 x's over here. I did the same thing to both sides. That's the subtractive property of equality. So I know that my equation is going to stay equal, and this is going to go away. So that's going to leave me with x, because I had 3, I took away 2, that leaves just 1 x left over. You can put a 1 in front, but that's 1 x that I just drew right there. It's 1. They're not multiple x's for sure. There's 4 equals 3, because those guys canceled out. Okay, so now I need to get rid of this 4. X is being subtracted by 4, so I'm going to add 4 to x. And I have to do the same thing over here. That cancels out, and I get x equals 7. Always showing our work. Oh, more. Okay. Oh, the 5th page is just what I wrote, so we're almost done. Okay, we're justifying steps again. They've got this. What did they do first? First, they did this to both sides. They got rid of 3 a's from each side. There were 5 on this side. They got rid of 3, so there's going to be 2 left. There. Ugh, they did it in a weird order, but that's okay. So I added -3, so it says it's adding. So I'm going to say additive property of equality, because I am allowed to add the same thing to both sides. Okay, moving back to this. What happens next? Well, this, they switched these, right? So these switched. Anything else switch places? These switched as well, didn't they? Okay, well, when I switch the order that things are being added, that's another property we've learned a long time ago. That's the commutative property. 2 plus 3 equals 3 plus 2. Allowed to change the order that I add things in, as long as I'm still just adding. It's a rule that is kind of common sense. Here, it looks uglier because there are a lot of numbers. That's all that we're doing there. Okay, looking at what's happening next, we're deciding that we're going to add the first numbers each time. That's called the associative property. One plus 2 plus 3 equals 1 plus 2 plus 3. You don't have to type all of this, but it's useful to know because you might be doing this later. You might be using these things. Okay? So that's the associative property. It lets us add in whatever order we want. Next we have, let's see, we added these and they became 0. That's called, when I add a positive and a negative and they make 0, that's additive. Right. We'll add, because that's right here. Almost there. Okay, so what happened next? Oh, this A, they took it out. Man, that is quite a fun one. This is called factoring, and it's based on the distributive property. Remember how if I have something outside of parentheses, I have to distribute it? We are undistributing. So it's using what we would call the distributive property. So we would call this is just a lot of fun stuff. Distributive property. Okay, factoring is going to be really important later in math. Okay, it's a really weird one to get your brain around, but it's very important and useful later. Okay, so now I can add these guys, 5 and negative 3. 5 minus 3 equals 2. That's all. Okay, and finally we've got 12a. 12 equals 2a plus 7. What happened here? Oh, 0 plus anything is itself. That's called the additive identity. Adds that's a good one. It affects nothing. It preserves the identity of that 12. 0 plus 12 makes 12. That's all. Pretty exciting stuff. So I'm going to use some fancy words here. That's good for us. If you used another way to explain it, I'm not going to mark you down, but it's very useful since you're watching the video for you to get used to some of these words. So we're going to solve the rest of it. 2a equals plus 7 plus 9. Okay, so I want to get rid of these things around the a. We always start with adding and subtracting, and then we work to multiplication. So I'm going to get rid of the 7 first because it's adding and subtracting. It's adding. So if I add something to 7 and then I take away a 7, then I get the original number back, right? I add 7 to it and I take away 7, and I get the original number. So right now I have 7 more than 2a. 7 more than 2a. So if I take away 7, I'll be left with just 2a. 12 minus 7 is 5. Now I know that 2a equals 5. Now if I take half of 2 a's, that's 1. Think if I have $2 and I have half of that, that's just $1. If I have 2 a's, whatever number a is, and I chop it in half, and I only have 1 a. And that's our goal. So I'm going to divide everything by 2. Oops, when I do that, there, these are going to cancel out just like those did earlier. Okay, that's going to leave me with 2.5 equals a. And some people will want you to write a equals 2.5. I don't really care, honestly. Because anyone who's gotten this far in math knows that these are the same statement. But it is useful to know that problem is there. So let's try that. 2.5, I plug 2.5 in here, I get 2.5 times 2 makes 5, plus 7 equals 12. Very good. Okay, now remember, you can solve these faster ways, I'm sure. However, we're learning this process and we're learning how it works so that later in math, when you do crazy complicated assignments and problems, you will know how. Okay, so it's a very common thing at this stage in mathematics for people to solve things because they're good at math, quotation marks. And you are. You're great and you're smart and your brain works wonderfully and there's nothing wrong with that. However, writing down the steps is very important because I guarantee you, I can write a problem that you can't solve in your head. Even with a calculator, you'll be like, wait, I don't know what to do. Yeah, and that's why we learn all of these steps and we get used to them so that later in math, when you come across something truly complicated, you have the tools to do it. So please, always show your work, show the steps, show what you're doing to both sides, show what cancels, and that's plenty. Okay? All right, have a wonderful time doing math.